Hello everyone, good morning to all. I hope you all are preparing sincerely and seriously for your examination. This is a new video related to application of derivatives and today's topic is tangent. So in the next video I'll discuss normals with you. In this video I'll discuss about the tangent. So let's start. First of all, let us discuss that what is the meaning of tangent. Okay. So in very easy language you can understand tangent in this way, that tangent is just a line that touches the curve at one point. Suppose this point is x1 y1, then tangent is a line that touches the curve at this point. Okay, it does not intersect the curve, it only touches the curve. Both things are very different. Here we are not using the word intersect. In intersection also it actually intersect at one point only, but that is not the case. Here the case is it touches the curve at one point. So remember this. So tangent is just a line that touches the curve at one point. Okay, this is the definition of tangent. Now how to form the line? Okay, so for formation of the line we are going to use few of the concepts that you have already studied in class 10th and 11th. So what is the equation of the line passing through a point that you have studied in class 11? So the form is y minus y1. If the point is x1 y1, then the line is y minus y1 equals to m x minus x1. And what is m here? M is the slope. Now as we are saying, we are calling it the application of derivative. Why? Because in the geometry of differentiation I told you that what is the meaning of differentiation? Differentiation is nothing but it is the slope of the tangent at that point. So here we are going to calculate m with the help of differentiation. That's why this is the part of application of derivative. So differentiation is involved in calculating the slope. Okay, so slope at that point, and what is the point? x1 y1. So this can also be written as, if the graph is fx, then we can call it f dash and point is x1, so x1. Okay, so this is your slope and this is the form of the equation. Now combine both, replace this m with this, so you will get y minus y1 f dash x1 into x minus x1. So this is the equation of the tangent at a particular point. Okay, so this is very basic geometry. Now what is next? There are the two cases. Okay, if a tangent line, suppose the tangent, this is the curve and the tangent is making the slope theta, okay, with the positive x direction of x-axis, then in that case this becomes tan theta. So in that case you are going to replace m with tan theta. Sometimes they give you theta, so in that case you are going to use tan theta for the slope. That also you remember. So for that dy upon dx, that is nothing but the slope will become equivalent to tan theta. Okay, now what is the case? The first case, here it is written that if slope of tangent line is 0. Okay, slope of the tangent line is 0. What is the meaning of that? Your equation was y minus y1 m x minus x1. This was the equation. Now they are saying that slope of the tangent line is 0. It means m becomes 0. Slope is 0, it means theta is 0. Theta is 0, it means tan theta. Slope is 0 means tan theta becomes 0. So in that case this becomes 0. So what is left? Y minus y1 equals to 0. So y minus y1 equals to 0. What is the meaning of this? It means y equals to y1 is the equation of the tangent, and y equals to y1 means that the line is parallel to x-axis. Line is parallel. It means in this case the tangent will be parallel to x-axis in the first case, and in the second case your theta is pi by 2. If your theta is pi by 2, and tan theta will become infinity. Infinity is 1 upon 0. So 0 will be multiplied here. So this will give you x minus x1 equals to 0. So in this case the equation will become x equals to x1. It means this will give you a line that is parallel to y-axis. So in this case you will get parallel to y-axis, and for this case you will get parallel to x-axis. Okay, So these are the two cases. Generally sometimes the question is being asked of 1 mark, that what will happen in this case. The tangent will be parallel to x-axis or y-axis. So you should remember all these concepts. Okay. Now you see the questions that are very easy. In the first example, find the slope of the tangent to the curve at the point whose x coordinate is 2. X coordinate means x1 is given, that is 2, and this is your curve. So how to find out the slope? By calculating the differentiation. So we are going to calculate y dash. So y dash will be, obviously you are going to differentiate it with respect to x. So this will become 3x square minus 1, and derivative of constant is 0. Okay, so 3x square minus 1. Now x coordinate is 2, so put 2 here, so you will get 3, and this will become 3 into 4 minus 1, so this is 11. So at x equals to 2, the value of the slope is 11. So very easy calculation, only the concept you should know. Okay, now the next example, that is also very easy. Find the point on the curve this at which the tangent is this. See what is given here. They have already given the tangent to you, okay, and the curve is also given to you, and they want you to calculate that point. It means they have given the curve, they have given the tangent, and they want to know this point. Okay, how to do that? If you have the curve, you can calculate the slope. Okay, and if you have this tangent, then also you can calculate the slope. If you are going to equate both the slope, then you can find out the point. Okay, so how to do that? Just see. First of all, we have this curve. Let the point be x1 and y1. If the point is x1 and y1, then equation of the tangent should be this, that we have already studied. Now suppose if the curve is given this, so how will you calculate the slope? By differentiating this. So y dash, if we are going to calculate y dash, then we will get 3x square minus 11, and the point is x1 y1, so this will become 3x1 square minus 11. This is your slope. Okay, now they have already given the tangent to you, that is y equals to x minus 11. This is the slope of the tangent that you have calculated with the help of the curve. Now they have already given the tangent, so slope will be same. So this is y equals to x minus 11. So the form of the equation is y equals to mx plus c. So if you are going to compare here, the slope will be 1. Y equals to mx plus c, and the value of m will be 1. So we are going to use this value, and here you can see that this equals to 1. Now we have compared both. First of all, we have calculated the slope with the help of the curve by calculating the differentiation, and the second, they have already given the tangent to us, so we have calculated m by comparing it with y equals to mx plus c. So we have equated both the slopes. So in this case, if we are going to calculate the value of x1, so we will get plus minus 2, and our curve that was already given to us, that was x cube minus 11x plus 5. Why we are writing x1? Because the curve is passing with the point, through the point, so we can replace x with x1. So x1 we have calculated either plus 2 or minus 2. So first of all, we are going to put x1 equals to 2. If we put plus 2, then we get y equals to minus 9, and if we put minus 2, then in that case y1 value is 19. So we got 2 points, minus 2, 19, and 2 and minus 9. Okay, so these are the 2 points. These are the 2 points with which the curve can pass through. Okay, so these are the 2 points that we got. Here you can see what was the curve. That was the curve y equals to x cube minus 11x plus 5, at which the tangent is this. So we have to find out the point on the curve at which the tangent is this. So this tangent we can find at 2 points. So if we are going to draw, we can find out 2 tangents at this point. So different points, minus 2, 19, and 2 and minus 9. So just go through these examples, try to draw the geometry of them, and then only you can finalize whether you got the point or not. Do all the question related to the exercise and some extra questions also, and if you have any doubt or query, you can ask and post to me. Okay, thank you so much.